compartiéndose. ¿Estás viendo la compartido? ¿Sí? Yo digo que si podemos empezar ya, yo como que lo que digáis.
Ah, no,
¿Sí? Muy bien.
¿Vale?
Bien.
Sí. Ah, vale. Sí.
Un laptop to present anything?
Still have 15 minutes. Just waiting for people to trickle in.
Sorry. Are you Nikki?
Yeah.
Okay. Are you in the Google Meet?
No. Yes, I think. I don't know who the person.
Your email address?
Okay.
It's in order to be recorded. Sure. Join the meet and share your screen. And your camera, please. Screen. Okay. Perfect.
Okay. So the curtain go by. sharing
You
the.
need to do a slideshow. Yeah.
Just slideshow that
Yeah.
because it shows my browser.
Sharing.
Let me check this.
Okay.
But I'm not sharing the screen.
You want me?
When I'm sharing, it shows my browser.
Share the meet is better.
Nice. Yes, then there was that. Yeah. Thank you. Yeah, we can. Not 45. Oh, yeah. Okay. Can go from this. You want me to move this? Yeah, I just want to make sure everyone's here. Hello? Okay. This works? Yes. Hi, everyone, and welcome. Today, we have the local chapter of Cloud Native Barcelona that is relaunching. So that is part of the CNCF, the Cloud Native Computing Foundation. And we are also presenting as part of the CNCF Sustainability Week, which is this week, second week of October, in 21 cities around the world. We are all meeting to discuss environmental sustainability in the cloud native ecosystem. So just a show of hands, how many of you are familiar with Kubernetes? Maybe you use it yourselves, or at least familiarity to some extent. And to how many of you is Kubernetes completely new? Like, okay, good to know. It's good to know also for, when we're defining terms, to know the experience of people. So by the way, I'm Nikki Manoledaki. I'm a software engineer at Grafana Labs. I'm also kind of founded the environmental sustainability tag of the CNCF, which I'm going to explain more in a minute. And So like I said, 21 meetups, we have daily blog posts, we have a daily live stream as well. We have a mini conference on Thursday where we're going to hear from various people about cloud native sustainability. And what is the CNCF tag? So we're talking about the Technical Advisory Group for Environmental Sustainability. So in the Cloud Native Computing Foundation, which is part of the Linux Foundation, we used to have SIGs, which is special interest groups, and those were formed around Kubernetes to share experience, like coordinate releases, docs, etc., and lead the development of, for example, Kubernetes, which was the first tool to be donated to the CNCF. And later on, SIGs became only groups, special interest groups for Kubernetes, and we created tags, technical advisory groups, for other things such as environmental sustainability, which is one of the latest tags, as well as app platform is a tag which has the GitOps working group, for example. We have tag observability, etc. We have tag security, so we have tags for these kind of themes, and then the CNCF projects such as Kubernetes, Prometheus, Flux, Argo CD, etc., that are donated to the CNCF are often coordinated under those tags. So this is what a tag is. And the environmental sustainability tag was created about a year ago, and we support the community around the topic of environmental sustainability. We advocate for it. We help with talks and organizing events such as this one. We have some working groups. One of them I'm co-chairing is the Green Reviews Working Group. I'm going to talk about that in a minute. And we also do demos of tools, like new open source tools that can help with sustainability. So you're always welcome to join. Those meetings are open to everyone. They happen twice monthly. I would encourage you to come if you're interested in getting involved with the CNCF more. Everyone is welcome. So we have a landscape document that we created a year ago, and in this document we go over different issue areas like energy monitoring, carbon monitoring, carbon-aware scheduling, what is FinOps and how it relates to sustainability, etc., as well as we have a list of tools that are relevant. And we're continuously adding to this, so if anyone knows of anything, they can add, they can just open a pull request on the repo where it lives. So we have the green project reviews. So this is very exciting. It's the first technical project of the tag. And so our goal is to create a pipeline to evaluate the sustainability of CNCF projects. So we're using infrastructure that was donated by Equinix to the CNCF, and we're deploying energy monitoring tool called Kepler to evaluate how different tools operate under different scenarios, like basically benchmark testing. And then we're going to analyze, assess this, and make recommendations for improvements. We're planning we have a working group around comms, so this is basically raising awareness and planning, for example, hackathons and other initiatives. And then the things that are in lighter green are being planned, so we want to do a maturity model. What this is basically assessing where you where you are now and where you could go next to evolve the environmental sustainability of your infrastructure. So this is still in the works. It's kind of inspired by the GitOps maturity model. I think there's also security maturity. There's a various maturity models that look at where you are and how you can improve. How can you contribute to this effort? You can join the CNCF Slack channel. So if you're not a member of the CNCF Slack, you can find invites online if you just search CNCF Slack community invites. It should be the first result. Then you can join the Slack channel, and we're very active, especially this week. Everyone's posting photos of the meetups, like yesterday was Amsterdam, Munich, like a bunch of different cities posting events, photos of their events. So please do take photos and post them on the channel. And you can also look at our repo. And there should be, I think, in those flyers that are around the room, there's 3 or 4 of them, you can scan and find like a link to the repo and other resources. So that's what they're here for. You can ask, if you're interested in a specific thing, we can help you find other people who might be already doing this that you can learn from. If not, we can guide you for, how to grow your project. You can do a demo in front of everyone, one of the meetings, etc. Or it depends what each person is interested in. And we have some contributing guides and resources. We also have a mini conference on Thursday, so if you'd like to, I think it's around 5 p.m. I think 5 or 6 p.m. I'm not completely sure. But you can find out more on this link about what we're doing this week. There's also a survey. If you'd like to give us feedback about this event, you can leave some feedback. There's a QR also on the flyers, so you can share your thoughts on what you learned or what you think about this issue. And we would really appreciate this feedback and just some sentences from the community if you'd like to share your thoughts and suggestions or ideas as well. And I think there is a gift code for CNCF certification and courses, I believe, that you can get a discount code for. So this is the local edition of the Cloud Native Sustainability Week. We are also relaunching Cloud Native Barcelona. So thank you to all the people who have helped, who are around the room, who have helped to bring Cloud Native Barcelona together in the first place and to help relaunch it since, I think we hadn't had events since 2019. So it's really nice that we can come together again and continue the journey of, creating, empowering the community of engineers and technologists who work in the cloud native ecosystem in Barcelona. So this is our agenda. We started with the introduction. We're going to have talks until 8:15, 8:20, and then we're going to have some food over on the side. Thank you to Grafana Labs for sponsoring this event with food and drinks. And thank you to Wallapop for hosting us in this space. It couldn't happen without you, so yay. And without further ado, let's start with our first speaker, if you'd like. I should mention we're going to have the first talk in Spanish and then 5 in English. We're still working on the multicultural aspect of our event. I don't know if we could have done this better, maybe with someone's translating in Spanish. Please let us know. Your feedback is welcome. Thank you.
Hola, muchas gracias por estar aquí y sobre todo gracias a la organización y a los sponsors por permitirnos poder hablar en la comunidad. La charla que voy a dar hoy es ¿qué es FinOps? Supongo que todo el mundo conoce FinOps. Habrá alguien que no lo conozca, pues bueno, tendremos que hablarlo un poco más adelante, ¿vale? Y lo que es la sostenibilidad en el cloud. Es un equilibrio entre la eficacia financiera de nuestro cloud y la responsabilidad ambiental. Para aquellos que no conozcan FinOps, vamos a hablar un poquito de qué va esto y la sostenibilidad cloud, cómo se relacionan y un pequeño, como vengo del mundo de Microsoft, pues he puesto un pequeño Azure, anexo en Azure, pero que es extrapolable a todas las webs, a todos los clouds. FinOps y la sostenibilidad cloud son dos conceptos distintos, pero complementarios. Uno, ambos se centran en optimizar las tecnologías de IT, pero tienen unos objetivos completamente diferentes. Actualmente, cuando se vende sostenibilidad, se está vendiendo con FinOps. Estamos llevando las FinOps a las empresas y después metemos la cuña de sostenibilidad. Me he dado cuenta que muchas de estas presentaciones en las cuales he participado tiempo atrás, estábamos errando en este tipo de venta, porque posteriormente te vas dando cuenta que no persiguen el mismo objetivo, incluso es un error. Para aquellos que no sepan qué es FinOps, Financial Operation, es una práctica para la gestión financiera y al fin y al cabo es reducir costes y optimizar tu cloud. Es una forma de medir y tener unas medidas realmente fiables, es decir, pones métricas de consumos, etcétera, pero tu fin es reducir el coste económico, es decir, bajar el dinero, bajar los euros. ¿Cómo se suele hacer esto? Por ejemplo, una de las grandes cosas que he visto es, por ejemplo, os pongo un caso real, una Redis caché sobredimensionada. Tú llegas, empiezas a verlas, al principio del proyecto dices, no, es que ya tenían millones de datos y no llegan a 1 giga. Cuando haces un estudio, revisas, ves ese recurso en concreto, ves que al final, en vez de gastarte 500 euros mensuales, con 300 euros habrías hecho lo mismo, incluso es grande. Pero una vez hecho el estudio puedes ver que puedes reducir ahí. Igual que son 300 euros al mes, multiplicas por 12, pero es en la Redis, son máquinas virtuales que tenemos sobredimensionadas o base de datos que no necesitamos que sean tan grandes y con un modelo más pequeño, en cualquier cloud, pasa no solo en Azure, reducimos. Entonces su orientación es cuánta pasta tengo, cuánto dinero tengo, cuánto dinero os puedo dar para las empresas, es decir, yo este año tengo un budget de 100 millones de euros, o ponemos un dato, y solamente puedo gastar 10 en la infraestructura. Todos los años van bajando precios de máquinas, etcétera, y si mantenemos las máquinas antiguas, si no hemos optimizado, estamos perdiendo dinero. Se lo estamos regalando al cloud, por así decirlo, pero es que también a los cloud les interesa que sus máquinas potentes se utilicen lo menos posible para que puedan dar servicio a otras menos potentes. Aquí aparece la sostenibilidad del cloud. Esta palabra que empieza a sonar mucho, que se llama GreenOps, que se va a dedicar que las operaciones vayan enfocado al ser verde, a consumir menos energía. El objetivo en este caso no es reducir el coste económico, aunque como ya decías, están estrechamente ligados. Viene a ganar un punto en un índice que se llama RG, que este índice Environmental Social Governance, que he puesto una coletilla, ya compartiré también en mi web esta presentación y aparte la tenéis en el vídeo, lo que vienen a ver es un dato intangible. Ese dato intangible nos sirve a muchas empresas para conseguir inversión. Es un lavado de cara y también, como conocéis, la guía de 2030, donde tenemos que ser cero carbon, pues empieza a aparecer esta medida. Esta medida hay quien la tiene, cada uno, cada cloud, cada herramienta de medición está utilizando la suya. Aquí entra en juego la Green Software Foundation, que está intentando tener un indicador coherente para todo el mundo y que se convierta en un estándar. Al fin y al cabo, lo que se pretende es ver que nuestra empresa está comprometida con el medio ambiente y que estamos intentando emitir menos carbono. En on-premise es bastante complicado encontrar a un proveedor que nos dé esa energía eficiente, que sea todo sostenible, mientras que los cloud ya no lo dan todo hecho. Por eso creo que es una de las mejores maneras de también vendérselo a todos los clientes. Es decir, oye, te vas a ahorrar dinero porque se puede medir y aparte estás comprometido con un tema que tienes que cumplir, porque en 2030 tienen que cumplirlo, terminarías con ello. Como bien dijo, aquí se relacionan en ambas para maximizar el beneficio de la empresa. Uno es por tema de dinero y otro es un índice social que hoy por hoy, tal como este punto de equilibrio, parece ser que debería ser equilibrado. Venga, vamos a intentar que ni tú financias ni tú green os llevéis el gato al agua. Pero es que desgraciadamente para los financieros y afortunadamente para la gente que queremos hacer las cosas bien, se está decantando hacia el green. He visto casos en los que antes no se promocionaba nada, eran empresas muy mal vistas a nivel social y han tenido que hacer una reestructuración, cambiar sus aplicaciones y empezar a vender que ellos tienen un compromiso. Una de las grandes empresas energéticas de este país ha sido la que está haciendo mucho hincapié, por ejemplo, en este tipo de trabajo. ¿Vale? Entonces, por tanto, para mí no son excluyentes, son complementarias y cuando hablemos de GreenOps, que sepamos que es una cosa que va orientada a un indicativo y financials a otro. Y que nos pase como a mí, que me pasó al principio, que estábamos vendiendo los ahorros de infraestructura, etcétera, orientada al cloud. Uno de los ejemplos que os puedo poner es que una máquina virtual desplegada en Australia todavía emite carbono, muchos sitios de Australia, en Azure. A lo mejor a un australiano le resulta más barato emitir en esa de carbono que en la otra que no está en otra región que no está con carbono. A mí me interesa vender, hacer ese swap, irme a esa máquina virtual. Hablo de máquinas virtuales porque es lo más fácil y llamativo. Por ejemplo, aquí en España nos pasa igual. Noruega emite mucho, tiene muchas plantas de energías renovables. Nosotros también tenemos aquí, pues tú puedes coger y balancear en Kubernetes, hay herramientas, etcétera. Ya creo que hay una presentación con queda bastante interesante al respecto, que lo que puede hacer es balancearte y moverte a un cloud más sostenible y menos sostenible. ¿Qué puede ocurrir? Que evidentemente estás gastando más dinero. Si tú sumas y ves que la máquina virtual barata en este sitio y haces este swap, este cambio, porque tienes que pensar que ya no son la máquina virtual, sino gastos de, ¿cómo se dice?, de la gente que la desarrolla, mantenerla, monitorizarla, etcétera. Al final, a la larga, ves que es un gasto económico. Entonces, ahora mismo, por ejemplo, es mi forma de contar a los clientes, decir, sí, te vas a gastar X, pero a cambio te vas a llevar Y. No como decíamos antes, no, es que con X, que es FinOps, también te vas a llevar Green. Y esto no era así, por ejemplo. Herramientas. Todos los clouds tienen herramientas. Yo conozco mejor Azure, entonces, pero también conozco AWS. Y AWS es el primero en sacarte en su Well Architect Framework una serie de pautas para que tú optimices tu cloud. Sin embargo, por ejemplo, Azure, a pesar de estar en la Green Software Foundation, Microsoft, ellos tienen una serie de assessment o análisis o casos de uso orientado al green. Supongo que esa tendencia tiene que cambiar porque los pilares de la Well Architecture Framework, ellos no tienen ese pilar, sin embargo, AWS sí lo tiene, entonces tendrá que empezar a cambiar. El tema de la Green Software Foundation, ¿por qué la menciono tanto? Porque, bueno, entre una de las cosas es que tiende a hacer ese valor SCI, que es un valor Software Carbon Intensity, que pretende ser agnóstico, y porque también, si os interesa profundizar más y de manera gratuita, hay un certificado de la Linux Foundation que os puede permitir indagar y ver cómo afecta esto a nuestro trabajo. Yo he hablado del tema de FinOps y GreenOps, pero si alguien es un desarrollador o es un nivel C, también va a encontrar información suficiente para poder entender cómo aplicar este tipo de acciones. Lo único que, claro, estamos hablando que el SRG es marketing social, no es tangible, y ahí es un poquito concienciar a las empresas para que puedan entrar a ello. Por mi parte, no sé si he ido muy rápido o no, me sobra mucho tiempo o no. Quería ser conciso. Perfecto, gracias. Si quería ser muy conciso, quería que os llevaseis el mensaje de esto no es esto, sin embargo se complementan, y que cuando alguien os empiece a hablar de este tipo de... penséis que alguien ya había cometido un error antes. Pues llevo trabajando en este tipo del green y vendiéndolo a las empresas hace 1 año y medio. Te das cuenta que con el paso dices, vaya, he estado contándole cosas a gente bastante importante mal. Y es un poco, pues eso, un poco vergonzoso, y es por el desconocimiento, porque como acaba de arrancar, entre comillas, pues era necesario, desde mi punto de vista, separar estos dos conceptos y que salgáis de aquí claros con ello. Por mi parte no tengo mucho más que contar, no sé si tenía no tenía ninguna diapositiva más. Lo que sí me gustaría es, si alguien tiene alguna pregunta, aprovechar estos minutitos para intentar resolverlo. Y si he ido en algún punto muy rápido, pues poder repetirlo. No sé si...
Sí, yo tengo aquí una pregunta. No sé si has trabajado ya con alguna empresa en la que ya estén en una situación. ¿Cuál es el plan de acción? Primero me imagino relevar los datos, saber la situación de la...
Medir, medir y medir. Cuando tú mides, vas a sacar siempre cosas relacionadas con FinOps, ¿vale? Y empezarás a decir, vale, es que esta máquina está sobredimensionada, esta la otra, y vas a ver que indirectamente te va a llegar a GreenOps. Lo que pasa que, claro, cuando llegas a GreenOps, si no lo sabes, piensas en que también ahorro con GreenOps, y no es así. Tienes que estudiar esa variable que es dónde están alojadas esas máquinas, qué índice de contaminación tienen y sobre todo qué cloud estás utilizando. Azure, Google, AWS tienen un compromiso. Azure es 2025, 2030, cero carbon. Las que lo tienen todas venden su forma de trabajar. Cuando vas a otra nube que no la conoces, ahí es donde tienes que trabajar. Si estás trabajando en on-premise, ahí es cuando tienes que sumar a tu estudio, de decir, vale, es que tenías que reducir esta máquina que tenías comprada hace muchos años, y decirle, oye, es que esta máquina, por mucho que yo quiera cambiarte los proveedores de luz, etcétera, consume mucho vatio. Consume mucho y al final no vas a ahorrarte. Pero en principio, el punto de partida casi siempre es FinOps. Después es observar de dónde te estás yendo, a qué máquinas o sistemas SaaS o PaaS, da igual lo que utilices, que tengan esa posibilidad. Hoy en día hay muchas herramientas que se meten y se incrustan. Por ejemplo, Office 365 tiene herramientas para poder medir cuánto carbono estás emitiendo. Por ejemplo, en Dynamics, que es una de las grandes herramientas de contabilidad, CRPs, etcétera, también miran hasta la posibilidad de tus trabajadores cuántos kilómetros están haciendo o no. Eso ya no tiene nada que ver a lo que estaba hablando, que era infraestructura prácticamente. Estamos hablando ya a otro tipo de herramientas. Al fin y al cabo, todo esto se está metiendo alrededor, pero con tu pregunta, por poner un punto de partida, sería empezar a hacer un estudio de FinOps y ver dónde puedes optimizar para bajar. Siempre que bajes, los clouds siempre será más barato económicamente y en teoría los clouds ya tienen que ser en 2025 cero. No sé si tenéis alguna preguntita más o por mí ya estaría todo. Pues muchas gracias y...
And the next person. So we're starting with you can already set up, yeah. We're starting with a FinOps aspect. We're going to go through energy consumption and efficiency, and then we will finish with some carbon-aware scheduling and looking at carbon specifically. So that's kind of there's some echo. yeah, that's going to be the journey for today. So.
Yeah, it's better. Hi. Someone actually answered. Thank you. That's nice. That's sweet. Okay. So my name is Paula. I am a senior software engineer at Grafana Labs. And thank you so much, because this is actually a pretty well segue from your talk. You want to measure. Welcome to Grafana Labs. We measure stuff. So the first thing, the talk is called how to, or subtitle, how to sell your sustainability projects internally, right? I'm going to assume if you're here, you have at least some interest in sustainability. The problem is, yeah, you kind of gotta get paid at the end of the month, and your business needs to make money to be able to pay you. So this is where this comes in, right? We oftentimes talk about sustainability as if it is immediately environmentally friendly. That's not necessarily the case. Again, going back to the balance that we were talking about in the previous talk, we have to find a way to make more environmentally friendly choices that still make sense for the business, that still are sustainable for the business as well. I'm assuming you again are familiar with this. This is the endless cycle. Usually what we stress is reduce, reuse, recycle. There are a few more R's that are here and there, but these are the main ones that we have heard about. Of course, when we're talking about our daily lives as developers, there's not a whole lot that we can do about recycling our servers or reusing them. That all happens on the cloud side of things, but there is a lot that we can actually do to try to reduce our impact, and that's what we're talking about here. So there's a difference between utilization and usage. When I say usage, that is your actual footprint, the amount of compute resources, the amount of nodes that you are using, instances. Utilization is how well are you making use of those resources, okay? So how much of that is actually being used by your workloads versus how much of that is just sitting idle, just there doing nothing. So if you manage to optimize your utilization, you can get a reduced usage. Less usage means less costs, but also means reduced footprint. Reduced costs is how you actually sell it to the business. Reduced footprint is what you actually wanted to do. So what I wanted to drive home here is, if we're gonna talk about how much is your bill for your cloud costs, CPU is actually a lot more expensive than memory, okay? So the graph underneath is actually just taken from Grafana. But if you see, memory is this yellow kind of blocks. And as you go up the number of instances, it does grow, but not nearly as much as the costs for your CPU go up. So your total spend is going to pretty easily be the same as your usage for as many times as, however, is the rate you're paying for. Again, this is just an example how to drive this home. This is how much these compute resources cost. This is published in the Google Docs. If you see there, this is for the Europe region, you can see that, again, the CPU is a lot more expensive than the memory. The distribution is up to an 88% of your costs is CPU. AWS is not as transparent. You cannot get this type of fine-grained detail from AWS, but you can kind of guess. Like if you look at their different instances, the distribution doesn't change that much. And actually, there are projects out there that do exactly that. There's going to be a fair bit of PromQL in this talk. Fear not, it's just a way for me to show you what we're doing with this at Grafana and what we're doing with this information. So how much is your total usage? We just use a basic cube state metric that is this cube node status capacity. You have this metric both for the resource CPU and the resource memory. I'm gonna be focused on the CPU. All of the next slides are CPU. You can do the same thing for memory. Because we saw the costs for the hourly rate, you just make a sum of all of your nodes. How much CPU are they adding up? And just multiply it for your rate. Make it a recording rule. Don't know if folks, you are familiar with recording rules, but these, as you start building dashboards, these metrics can get potentially expensive in terms of compute resources. Make it a recording rule because we are going to use this in dashboards, so you can make it easier on Prometheus and on Grafana to render all of this information. Again, same metric, just we gave it a name, we gave it a tag, and we sum them by cluster simply because at Grafana we have dozens of clusters, so we need this grouped. Give me a second. Okay, so this idea of idleness that I was talking about, this is heavily opinionated, okay? We measure idleness as the total capacity of your instances minus whatever your workloads are requested. This makes sense in Kubernetes terms, but this, again, is highly opinionated. Your total capacity is not really allocatable. There's compute that you need for your instances to actually run. We're just assuming the total here, and requests, well, it depends on how well your developers are actually setting your requests, but also a workload can use up more than their requests. Again, we are just assuming a best case scenario so that we can have data that we can manage. With that in mind, you can actually calculate how much of your nodes are actually doing nothing, just sitting idle. I'm sorry, I think that the air is killing me. I have not been out of the house that much lately. Again, we made it a recording rule. It's just your total capacity minus whatever all of your workloads are requesting. We label it CPU, we label it with this namespace. We say it's going to be called namespace idle, so that again, we can group that together and get some metrics that we can actually use. This ties us back into what I was saying. AWS is not so transparent into what exactly each costs. But if you use OpenCost, and if you navigate the code, this is open source, you actually see that they just make an educated guess. They run some calculations, and they tell you how much your CPU costs per hour. You get the same metric for memory. And then just because you have both metrics, right? At this point, you have recorded your total cost per minute and for the idle namespace and your total cost for the whole cluster. You can actually just make a ratio and watch how much of your cluster is just sitting idle. And you can make it an OKR. So this is what we do. We did this for last quarter. I mentioned this briefly on the abstract. These are actually our AWS clusters. And these drops that you're seeing here are from a migration that we did for our autoscaling tool. We migrated from cluster autoscaler to Carpenter, and WatchStar clusters got a lot more performant. So this is why you measure idleness and how you can drive that point to your business. That's it. If you have any questions, I will try to not die answering. Okay, that was a lot of bronchial. I'm sorry. Okay, then, if you have any questions later, feel free to catch up with me.
Thank you so much. So while we prepare for next talk, fun fact about Carpenter is that, well, it was created by AWS. It's now, there is a lot of traction to make it open source and potentially for it to join the CNCF. We will see. I'm not sure what's the latest news on that. But there's also a proposal to make Carpenter carbon aware. So someone, it's actually a university student, and he's also very active in the TAG. I completely forgot his name right now, but he's working to make Carpenter carbon aware so that some of the scheduling decisions can be made on the carbon intensity of the grids where your infrastructure is running. So we will see where that goes. You ready?
Thanks a lot. Okay, hello everyone. So my talk is about cost optimizations for Postgres clusters running on Kubernetes, and it's more about FinOps than GreenOps, but at least that's a starting point, right? Okay, so a little bit about me. My name is Dimitris Kapanidis. I'm a founder of a consulting company called Harbor Cloud Solutions, and I work as a platform engineer at SBB, which is the trains in Switzerland. I'm also co-organizer of the Cloud Native Barcelona meetup here. Previously, it was called Kubernetes Barcelona. Now I'm with a lot more people that we're doing together the meetup. And I'm also a member of Google Cloud Innovators. So a little bit about the SBB company. They transport more than 1 million people each day and 180,000 tons of cargo. They have more or less more than 34,000 employees that we work there. And in our team, basically what we do is we provide databases to the other teams. And we do it mostly, we give them Postgres instances, and mostly on AWS cloud provider, but we also use Azure and Swiss Cloud. And we use OpenShift, which is a Kubernetes flavor. And we run a PGO, crunchy PGO operator on top of that so that we can run our Postgres clusters there. We have more or less 800 databases running in general. So let's start with AWS savings plan, which is the easy part. Before we start with the savings plan, first what we did is we talked internally in the team, and we committed for 1 year to use that specific platform. And then we enabled EC2 savings plan, which is we enabled 1 year, no upfront payment, and we committed on 80% of our current workload so that we can have a little bit of room in order to reduce it with other mechanisms. And there's a different architecture, CPU architecture, like they have Graviton-based instances, which is an ARM processor. And I think those are a little bit greener, but we didn't enter on that field yet because we need to use different Docker images for ARM processors, et cetera, et cetera. But we're probably going to do it next year. So we already seen a 10% reduction in our costs. So yes, 1 click, 10% down. Now, let's go to the difficult part, which is Kubernetes. First of all, what is Kubernetes? Kubernetes is a cluster. It has many nodes. On each node, we have pods running, right? So how do we create pods? We have a deployment, creates replica sets, which creates pods, and those pods have containers. That's the easy part. We also have stateful sets that they can also create pods. And with PG operator, basically we create Postgres clusters, custom resources, which creates stateful sets, which creates pods. But at the end of the day, we just have pods running in Kubernetes. And we need somehow to create requests and limits for those pods. So what quantities do we put in the requests and limits? Well, we have 1G or 1GI, for example. The difference is one is gigabyte, which is a multiple of 10, and the other is a GB byte, which normally when we talk about gigabyte, we talk about the GI part, which is a multiple of 2. And computers work with multiple of 2, so normally we use this one. And the CPU, one CPU in AWS lingo is one virtual CPU, one vCPU, and that goes and counts how many threads are inside the CPU. And that's basically it. So when we talk about requests, we talk about how we allocate, how we schedule those pods in specific nodes. So the scheduler asks the system, where should I schedule this pod? And if the pod is big regarding the request that we have defined, then it cannot fit it in the node 1, but it can fit it in node 2. If it didn't know how big was the pod in terms of requests, then it wouldn't know how to do this kind of decision. And we have pods. For pods, we have quality of service classes, and there are 3 different types. The best effort, which is when we don't give any information, no requests, no limits. Kubernetes is going to do the best it can, but it doesn't know about the sizes of its pod. On the other side, we have guaranteed quality of service, which means that if we specify that the pod is 1 gigabyte memory request and limit, is going to be guaranteed that it's going to have that 1 gigabyte of memory. And in the middle, we have a burstable, which is when the request is less than the limit, and means that we have the 1 gigabyte of request, for example, but if we put 2 gigabytes of limits, it may have, or we may get into trouble. This is like something like the airlines that they sell us the ticket, and they tell us, yeah, you're going to have a place, but they know that some people are not going to enter in the plane, so they oversell the ticket. So basically, we're overselling our resources in the Kubernetes. And what happens is if the CPU is, if we define as a request CPU too low, what is going to happen is the CPU is going to be throttled. So the system is going to give us less memory, less CPU than what we have asked for, because that's what it needs, because we have requested less. And the system can take away CPU from us, because it's the CPU, you give it per minute or per second, so it can give us more at some point, but when it doesn't have it, it will take it us away. So this is a throttling. And this means that CPU is a compressible resource. It can be compressed when we don't have many resources. On the other side, memory is incompressible. If a process takes some memory, we cannot take it away from the process. So basically what we need to do then is we're going to do an out-of-memory kill. And that's what happens when you request less memory on a pod than what it uses, it will out-of-memory kill. And on the other side, if we give too high requests, then basically we're going to not be able to allocate other pods, because we're going to be left out of resources. And basically, it's a resource waste. And for the limits, it's more or less the same. But if you put it too high, then basically you're going to starve other pods. And if there is a competition between those pods about the limited resources you have. So how do we know what requests to put in the system? Well, basically, we can do that by just checking the history of the pod and see how much usage of CPU and memory has done in the last 2 weeks. And we take this information, we create an Excel, and we can calculate how much potential saving we can have for each database, notify the user to adjust their request so they can spend less money and they can have like a more adequate request definition for the database. And what about the limits? The limits, we can see the cluster CPU usage and the cluster memory usage by getting some graphs using Prometheus, Grafana, or other tools. And we are doing it with these calculations here, and we can see that we have a little bit of free or unused or idle resources, right? So we can improve on that. And in our case, what we had before is we had In non-production and the production, we used guaranteed quality of service, and basically meaning that the request and limits were the same. And what we applied now is basically on the non-production, which is our safer bet, where we want to start optimizing. We use burstable, and the request is at 75% of what the limits are. And the production, we've left it as is because it's a little bit risky to do an overcommit of your resources there. So our conclusion is that, in general, this is a work in progress. We're continuously monitoring also the system. And as a last side of note, I would say cost optimization is a process, not a task or a checkbox that you can just pick it and go on. It's something that you should always work on it and optimize. And that's about it. Any questions? Okay. If there's no questions, who is next?
Okay. If there are any questions, because we do have time. Nope. Okay, we'll prepare for the next one. I'm thinking of a fun fact to tell you. I guess that sometimes, well, we're going to talk about energy now. Sometimes I often see cloud-native sustainability as a triangle. There's carbon, energy, and cost, financial cost. Sometimes there are things that we can do that optimize for only two of the three things or only one of the edges of the triangle, right, of the corners. So, for example, with cost, with FinOps solutions, and we can reduce some of the costs in some ways, but we're not necessarily reducing carbon, and sometimes we can do both. So it's good to think of those trade-offs. And maybe an example for that is you can reduce your cost by moving to a region on AWS that is cheaper, but that's not necessarily reducing your carbon usage. Whereas some regions, such as, you know, EU North 1 in Sweden, it's more expensive for certain services on AWS, but the grid is using more renewable electricity. So think of those trade-offs. If you share your entire
I was sure to hear, yes.
Yeah. Share the whole window, otherwise it's just
Yes. Okay. Now I
and then you go to the and if you exit, can you exit your and then so I think we can do presenter view. Need to do just full screen. I think you need to show. Do you mind if
I think that you have to share the entire screen.
Oh, the entire screen.
Yeah, we did.
Really,
Why is the clicker not working? Let's try.
mine. Okay, so this.
Yeah.
Sorry. Not because I want to use it.
Okay.
But it's. Okay. So we have to. Okay. Okay. Good evening, everyone. First of all, I will to thank the organizers for the invitation. My name is Jalal Laklili. I'm from EIS. You will know it in the second slide what is EIS. I'm HPC engineer there, high performance computing engineer. And today I will talk about how to be an energy efficient data center with EIR. And also you will now know what is EIR. So here we go. First, EIR. It's energy, the name is energy aware runtime. It's a system software energy for energy management for modern data centers and also for traditional supercomputers. It's used with the architecture like for CPUs like with Intel and AMD and also with GPUs with NVIDIA and Intel. Here you have one overview to summarize the main component of the software. We have two basic parts for the energy monitoring and energy accounting. And the top, the part, very important part, is for energy optimization and management. So for EIS is the company. It's stands for Energy Aware Solution. It's from BC, Barcelona Supercomputer Center, and UPC, the University of Catalonia. It's a spin-off funded just 3 years ago and offers professional services to install ER and tuning it and also to have special development. So ER, it's an open source software and the EIS have the added value to help for the tuning, for installation, specific needs. For example, here we have a list of our main customers. The installation we have one in LRZ, we have one of the biggest supercomputers in Germany, in Munich. They are using ER since 4 years now. We have another one in Netherlands. It's Snelius. They are using ER since 21. And just this summer, we installed in DF, Electricity of France, and it's operating there. And we hope that it's our plan also to install in Mare Nostrum 5, the new supercomputer of Barcelona Supercomputer Center. So now I will give you just one use case of ER and the relationship between what data centers needs and what ER offers. So you know data centers or supercomputers willing to reduce their CO2 footprint. I will not remember you here, it's mandatory nowadays. In some time, they want to manage and reduce their electricity bill with the cost of energy, it's also mandatory. And there are in some cases, they limit their power consumption. For example, some servers in some data centers or supercomputers, they have some constraints and they want to limit for them the power consumption. And also, on top of that, to be efficient. So to summarize, they want to take care of the planet and also take care of the electricity bill. So how we are doing it, does it? So it can be used dynamically and in transparent way to optimize energy. So we have some policies, for example, to reach, for example, which we have two policies: minimize energy to solution or minimize time to solution. It's one now in this area. And depend of this policy predefined for the cluster data center, and it's always on in the runtime and it's fully dynamic. And also they have a dynamic power capping. So for example, as I said, some nodes or some parts or some group of nodes, they want just to limit the power. So ER offered to do it dynamically. And also because ER collects a lot of amount of data run in the cluster of data center. So we have tools to do some workload analysis, application analysis, and also to have some data visualization. We have tools, and also they can to plug it to, for example, the Grafana, and to have nice graphs and dashboard. In another hand, ER provide some hardware monitoring, and we are able to detect some anomalies. For example, if in some nodes of some servers they have a peaks of consumption of power or temperatures, ER can detect it and report it to admin or system, and they can do some solution. So all those things are operated in the traditional supercomputer like LRZ in Germany or for EDF, and but also we did the test in the cloud. For example, in some European project we have tested in AWS, I think, and also some public and private virtual machines and also singularities. So it's tested and it can fit well with the cloud computing. So we are ready, and it's in our current stage and midterm to be also in the cloud. So why? Because it's dynamic. It will adapt itself to be available, whatever the hardware or software limitation in the cloud environments. So we have some plugins to add to just install the version with a requirement that they have in the clouds. It's not like in the traditional machine. And also it's flexible. For example, ER will support new cases different than what we have in the high performance computer application. For example, in the next releases, we will have this workflow support. It's coming soon. And finally, it's powerful. So we did also some tests with base C in some architecture like ARM. So, and we know that it's highly present in the cloud. So ER supports also to this kind of architecture, and then if you have this thing, you can get energy efficient architecture. So if you can see that ER and this product can fit perfectly in the cloud and to get benefit of the energy saving and to have less footprint of carbon. And I think also I fit in 10 minutes or less. So thank you very much. And if you have some questions, you are welcome.
Actually, I have a question. How do you work with the limitations for doing energy efficiency in the cloud, given the hypervisor that exists in the VMs in the cloud? So how do you measure? How do you deal with that issue? Yeah, or how do you measure? How do you do that migration to the cloud?
The trick here with ER, so we detect, for example, I will give you an example. So you have your application running in your machine, your cloud. So automatically we detect loops, and we compute some metrics, memory bandwidth, gigaflops, and then we estimate. We have some models to estimate, for example, the right frequency, the right power you will need, and for example, and to classify your application if it's more computational or more memory, or it's just in busy waiting. And then we decide to reduce the frequency of CPU or GPU, or for example, to pass, for example, it's just it's an idleness part of the application. So we decide to classify in which part, and then based in this estimation, we can give you the right frequency for application, and then we loop again. I don't know if I answer your question, because I'm not familiar with this part of cloud, but it's the normally what we use in the heart of the product.
Thank you. Are there any other questions?
Thanks for the talk. It was very interesting. Could you please describe how the actions of your software work in terms of reducing the footprint of the workloads? For somebody, for example, I don't really have a background of how on the machine level we can do that sort of optimization. So I'd like to understand it a bit in more depth. Thank you.
So we reduce, so to reduce the energy, so everyone, the provider of CPUs or GPUs, you have ability to reduce the frequency. So when you reduce the frequency of the application during the runtime, the power it will be reduced. You will have the time it will be increased. So you have some threshold also. So to have, for example, 10% penalization or less, you can define, this policy can define. So as I explained in our loop, when you detect the loop of not the loop, or for example, the phase of competition of the application. So we AR compute some metrics, and then we can classify the application, if it's computational, if it's memory. So for example, if you are using lots of memory and not lots of computation, so we don't need to have a higher CPU frequency. So we can reduce CPU frequency, and vice versa. For example, we can reduce also memory frequency in other case. And then memory frequency or CPU frequency reduced, or GPU, for example, the power, it will be reduced. The energy, it's power times time. And your energy, it's reduced. And your bill is reduced. So it's very, very summarized one part of the application, the software. I hope that it's clear, more or less.
Maybe one follow-up.
Yes.
So I can imagine that your application then makes use of a lot of machine learning to do the estimations, or classification.
Yeah, we have some models behind. For example, prior to install ER in a data center or supercomputer, we run a bunch of kernels of applications, and then we compute, we do some estimation of time, power, energy, and we have model. And based on this model, CPU model for energy model, we can estimate, for example, the energy and the power and frequency and so on. So prior we do some well-known kernels that we run for time and with different frequencies, and a lot. We have training part we call learning phase. We use it in the beginning, and then we have the model. And now we are working on other models for GPUs, but this thing it's fit in all architecture, so it doesn't matter it's cloud or not cloud, or ARM or Intel, whatever. Thank you.
While we prepare for our next speaker, there's also a tool called Kepler, which does very similar work. And it's interesting because of the limitation in the cloud, not with the hypervisor from the public cloud, that you cannot access certain information, like energy metrics, such as RAPL, which is like an Intel technology for providing energy metrics. The way to deal with that is, in that tool, is also through a machine learning model, which has been used on different types of CPU and is then used to estimate the energy consumption based on certain processes that it has already been trained on. So it's interesting to see how machine learning can be used for this, to fill the gap when we cannot access certain information, and we can create the algorithm to fill those gaps. So, all good?
All good, I think.
All right.
Hello, can you hear me? It's gonna be a bit hard to get your attention with all that pizza smell in the room, but I'll make my best. So my name is Daniel. This talk is called A Greener Cloud Computing Meets Sustainability. It's let's say, a shorter version of a larger talk that I gave at DevOps Days Geneva. You can access that talk in that QR code. Before we start, maybe it would be good to energize ourselves. So maybe a show of hands, who of you are developers today? All right. Infrastructure, platform engineers? Okay. Maybe a product manager in the room? Ah, interesting. Okay. So yeah, most of this talk, it's based in my experience, but also in the it's coming from the knowledge base of the Green Software Foundation, which is also part of the Linux Foundation. And yeah, until very recently, I was working exclusively in this, let's say, intersection of two domains, let's call sustainability and information technology. Although today I stand here as an independent developer / advisor. So maybe to kick us off, it's good to understand why today's meetup actually matters, right? So it's this overarching goal that we have as a society to keep global temperature below 1.5 degrees of, with respects to pre-industrial levels. And the IPCC is kind of like the leading authority there. And yeah, basically the main highlight of understanding this why is, at least to me, that this is not just a technology problem, right? So there's no magical silver bullet that will help us solve climate change. We need to tackle this problem a little bit more holistically. We need to have public policy in place, hold organizations accountable. Maybe we need to rethink our, let's say, consumption-based society and move away a little bit from it into something that nobody actually knows what it looks like, especially now with the advent of AI and the rethinking of jobs. So yeah, that's food for thought. The main goal of this talk is to be thought-provoking and to normalize our knowledge. Maybe another show of hands, who of you have heard some of the terms that we have shared up to until now, like carbon intensity? Do you know what that is? Okay. Carbon awareness. Great. All right. So yeah, okay, from the point of view of technology, you might think that what we do in our field, it's negligible or tangential. And intuitively, you might have a point there, but then there's some data that tells us a slightly different story. So just to play it conservatively, you have the International Energy Agency here with a, let's say, work in progress report, because this is a hard problem, trust me, saying that approximately 1% of all GHG emissions, global greenhouse gas emissions, that we can account for are coming from data centers and data transmission networks. So to put us into perspective, then you have some data that can, put right next to it the aviation industry, let's say, with a little bit below 2%. So it's not too far-fetched to think that these two numbers can catch up eventually, especially with high-performance computing being run in the cloud, or our subscription-based economy and how it is scaling, and now the advent of AI, running and training those machine learning models is not for free. And to me, that's mind-blowing, the fact that the work that we do, as technologists can have as much as impact as the aviation industry. And if the pandemic shows us something, is that technologists, tech workers are willing to do something about this, just as much as, quitting their jobs and funding their own companies. But that's kind of like a, extreme case. We don't need to quit our jobs yet. We can make them a little bit greener, if you will. So yeah, that's the original purpose of this talk, from the perspective of where we sit, what can we do, right? As software engineers, developers, infrastructure engineers, etc. Who has seen this before? All right, I'm glad. What I've seen is that the discussion, a good starting point for the discussion is how can we, let's say, embed a carbon accountable mindset, at each of these stages. That means analyzing, observing, and optimizing for one particular thing, which is carbon emissions or carbon efficiency. I say one particular thing, but it's a little bit more complex. We can pull from that thread and understand a little bit better. So yeah, going back to Green Software Foundation terminology, we can talk about green software applications that emit less carbon, basically. Again, if you break down this tree, on the left part, we can talk about carbon efficiency, changing code and architecture, so an application will emit less carbon, but also carbon awareness, changing the runtime behavior, so an application would emit less carbon. Let's go down this rabbit hole. Carbon efficiency. Do you recognize any of these aspects that you see on screen, these bullet points? So yeah, these are some, let's say, levers of things that we can play with as technologists that will have an impact in how much energy. Let's draw the boundary in a software application. I'm part of a team that is developing, I don't know, a microservice, a shopping cart microservice, right? So caring about algorithmic complexity, programming languages and their own abstractions, design patterns, and sometimes unnecessary abstractions that we add to our code, will have an impact in this particular metric. I mean, algorithmic complexity is something that is not new, right? It's been there for, I don't know, 50, 100 years or something, algorithmic analysis. But it takes the spotlight yet again because the cloud kind of like disrupted how we do things, right? So we spin up resources with the click of a button. Economies of scales have made it, quite cheap. So if we have a virtual machine running for longer than needed, who cares? But then maybe it's important to remind ourselves why a for loop inside of a for loop, matters. Infrastructure patterns. I mean, I think there's an argument to be made that using the cloud and being cloud native are not necessarily the same things, right? So making sure that we're using the right services, the right abstractions, etc. Let's take a look at the other side of that tree, carbon awareness. Basically, where we run our workloads and when we do so matters. And we're going to see why. There's an overloaded meaning to carbon awareness that I always like to point out, which is a little bit more user-facing, and it's when a digital product enables me as a user to make the sustainable choice. So you can see over there the Google Cloud Region Picker, which has a slider that tells you, hey, carbon footprint is an aspect that you can care for when you're going to choose a region in our network. The Green Software Foundation. It's an ecosystem, it's a community of people, organizations. They're working very hard into setting standards, practices, and principles. They are part of the Linux Foundation. It's a very welcoming space. I would encourage all of you to check out Slack, to check out GitHub. They have a lot of projects. Some of the ones that I wanted to share today is this SCI framework. I think it was mentioned by our colleague here. It's a model to actually, based on a boundary, try to come up with a number that tells you, hey, you know what? Your shopping cart microservice is X amounts of grams of CO2 equivalent carbon intense. There's a lot to unpack there, but that's the goal, to come up with the rate of emissions for a particularly well-defined boundary. This is another interesting project from the Green Software Foundation, the principles of green software engineering. That QR takes you to the certification that my friend here was mentioning. It's a 2-hour course that you can take for free, and it will guide you through all of this content. These are the 8 principles of green software engineering. They are principles in the sense of guidelines, heuristics, rules of thumbs, not principles as in Newtonian mechanics. The first 2 we already kind of saw when we briefly spoke about carbon efficiency. So carbon and electricity, they're closely related. We basically want to reduce the amount of energy that a process, and I'm being vague by what I mean by process here, but bear with me, consumes, because that will reduce the amount of carbon that process is taking. Now, I don't only want to use the least amount of energy, but I want to use the cleanest available energy, and that's carbon intensity. So if I run my workload here in Spain, and Spain suddenly power up all their fossil fuel plants, I'm making an assumption here, that carbon intensity score is going to be higher than if I were to deploy my resources, I don't know, Scandinavia or something, right? And these are trade-offs between different cross-functional requirements, because suddenly I might be a bit more sustainable, but then again, latency, availability, you need to care for multiple different things. Embodied carbon, if I'm a mobile developer and I'm developing a game, and I'm always targeting the latest operating system platform, I'm leaving out of the market perfectly capable devices that can still run my application, but because I'm not aware of the amount of carbon that it took to produce that device, then I'm not following that principle. Energy proportionality, basically you want to have a good utilization of your Kubernetes nodes. For example, I think Intel released a Kubernetes operator, power manager, I believe it's called, that reduces frequency of the nodes or something like that. Hopefully our friend is going to talk about that, or you know it. Okay, nice. So yeah, you want to get the more juice as possible from the power that node is drawing, basically, right? And measuring optimization, we're going to see a little bit more about that. But talking about carbon efficiency overall, does anyone recognize this picture? You know where this is? Just a guess. Say that again? Close. Not that close, actually. So this is Hamina, Finland. This is one of the locations in which Google has a data center. And as I said before, these green software engineering principles are more like heuristics or rule of thumbs. And making a lot of trade-offs and simplifying these very complex problems, one of the best heuristics that we have is to go to the cloud. Why? Google has one of the best PUEs in the market. Do you know what PUE is? Power user effectiveness, right? So it's a ratio that measures how efficient you are in your data center. And it's hard for me to compete with my own data center with this beast that takes water out of the fjord to cool down their systems, and then they bring it back to the ocean, for example, right? Just to give one example. So I must admit that cloud vendors have come a long way in the past few years into measuring carbon emissions for the workloads being deployed in their network. They realized there was a business case because their customers were asking them, hey, you know what? I need to report my emissions. Carbon emissions coming from the cloud fit in what we can call scope 3 emissions. It's one of 15 subcategories. And they have invested a lot. The problem nowadays is that if you're a modern tech organization and you're scaling and you are in a, very likely you are in a multi-account, multi-cloud environment, you might as well be measuring apples against oranges because we don't know their methodology. So yes, they're reporting a number to you, but we have no idea how they're measuring that. Maybe they're not. Maybe they're all oranges. We just don't know. We just can tell for sure. I'm proud to say that I was part of the team that built and maintained this free and open source tool until very recently. It's a tool that pulls from cloud usage data so that you can see energy consumption, CO2, and overlap cost to it. You're more than welcome to try it out and even to, have it running in production if you have the bandwidth for it. And again, one of the main advantage points here is that the methodology is open and you're free to actually try to smash it and make it better and contribute towards it. Whenever we talk about CO2 and measuring CO2, it's usually a combination of two things, operational emissions and embodied emissions. Operational emissions, let's call them runtime emissions. So the emissions of my VM running my shopping cart microservice, let's say. And embodied emissions, it's the emissions of the server that is hosting that VM in the cloud. something very hard to calculate with so many layers in between me and the cloud vendor. And yeah, that's how we calculate operational emissions, the service usage that we can pull from their APIs, some cloud energy conversion factors. Basically, hours of VM will basically translate to an energy measurement times PUE, which is this aspect that I mentioned just to you, and carbon intensity of the grid in which that data center, of the location of that data center. And I'm not gonna bore you anymore, especially with that pizza smell, but we can quickly escape this and take a look. As I said, this is an application that is cloud agnostic. You can even run it on-prem with the necessary adjustment. And you can come here. Oh, and Ali Cloud was just released. So yeah, it's basically cloud agnostic. You can also account for multiple accounts and multiple services, not all of them, that's true. And you can overlap CO2 here, see how it trends, compare energy and cost. Yeah, okay. To put you into perspective, a couple of web components showing what does this number actually mean, right? Because maybe you don't know if that's good or bad. And then a breakdown of emissions per region, per service, or per account. Always the most consuming ones are AI and data accounts, for sure, at least in my experience. And then the other interesting part here is kind of like a forecast and a table of recommendations. This pulls data from, let's say in AWS, it pulls from the Cost Explorer API, the right sizing recommendations, and also this particular service that is called Compute Optimizer, and it aggregates everything and show it to you. So basically, you can understand the result of your action. So let's say that I want to stop this VM. This will save me this amount of money, but this will also save me this amount of CO2 and this amount of energy. So that's it. I'm sorry that I ran through. That was a lot to unpack, but if there are any questions, I'm happy to take them, or feedback. So thank you.
Just to know the demo you show us, let's say I'm data consultant. I help a company to implement software like Power BI, let's say, and they want to put it not on their machine, but on public software, public cloud provider. How can we use this tool to help them have a choice between, okay, let the AWS is less footprint emitter?
Short answer is yes. The longer answer is you need to do a little bit of work, because you might need to do some experimentation as to which services you want to use. Maybe come up with an MVP and deploy it in all 3 different clouds and analyze the trade-offs, right? It's been a never-ending battle to actually talk to the cloud vendors and actually experiment with them, so that you can say, hey, you know what? I don't know. For whatever reason, lambdas are a bit more efficient than cloud functions, right? So the tool is free and open source. Is exactly for that, so that you can actually draw boundaries on this experimentation and define it by yourself. So proactively, the tool won't tell you that. It will be more like, yeah, okay, this is our use case. I do an MVP, I define an experiment, and then you can use the tool to actually measure it. Yeah.
I'm curious about this trade-off between using more efficient hardware and, deposing the old hardware that embeds carbon. Because, for instance, just recently I was seeing that people are just changing to new Intel processors that had much lower power, but they're thinking, okay, you are throwing away a lot of hardware. that nobody's going to reuse. So I'm not really sure that trade-off makes sense always.
That's exactly correct. Yes, I think relying on. So I think that there's a case that ARM architecture, it's definitely a bit more energy efficient than Intel, for example. Then again, you know, if you're gonna rely on a cluster that you made in your basement with, I don't know, 8086 processors, you know, from 30 years ago or something, just because you have them there, then probably it doesn't make sense. You're totally correct on that. Most of this, at least in my experience, we have had to do it on a by case basis, right? So no single answer on most of these principles, yeah.
I don't think we have time for more questions, but yes, you can find our speakers where the pizzas are. Thank you. Oh, wait.
So yeah, hi everyone, I'm Ross, and yeah, I'm going to talk about carbon awareness, and specifically time shifting with CADA. And so yeah, I'm a developer at Flatpeak, which is a startup that does API for devices like electric vehicle chargers, and lets them optimize on cost and on carbon emissions. I've also been interested in green stuff for a while, and I'm a contributor at the Green Web Foundation, which is a small non-profit based in the Netherlands. So before I talk about carbon awareness, I just need to talk briefly about renewable energy. And so the biggest benefit we get from renewable energy is the very low carbon emissions. So because we're not burning fossil fuels, the emissions are much lower. We still have to manufacture the solar panel or the wind turbine, but they're much lower. The other great thing about renewable energy is it's very cheap. It's now one of the cheapest forms of energy. And we also can have benefits in like energy security as well. But I think, as a lot of us know, the biggest problem is the variable capacity. So depending on the weather, how hard the wind's blowing or the sun shining, is how much energy we get. And so we have solutions for that with things like grid storage, but they're still quite new and they're still quite expensive. So time shifting is another way to make the most of the renewable energy that we have. And so yeah, to measure this, we need carbon intensity, like Daniel was mentioning in his talk. So this is actually a chart from the Green Software Foundation from their online course that's been mentioned a couple of times, and I really recommend. And so on the left here, we have quite a low carbon intensity of 120 grams of CO2 per kilowatt hour, and that's because we've got a lot of wind and solar. But on the right, if the demand stays the same, but the wind stops and the sun and it gets dark, we need to use more coal and gas, so the carbon intensity is increased to 350 grams. So you can see it can vary quite a lot. And so yes, so time shifting is that we run tasks when the carbon intensity is lower, and related to that is demand shaping. So we do more when carbon intensity is low, and we do less when it's high. But one of the important things is we can't do this for all workloads, because if it's something time sensitive, it won't work. But something like, for example, training a machine learning model, we don't need to do it straight away. So that could be a good use case. So what I did is I pulled some carbon intensity data. This is for mainland Spain, actually for this Friday. And I got this data from electricity maps. And so as you can see, during the daylight hours is when when demand is low, that's when the carbon intensity is lowest. And what typically happens is during the afternoon, kind of demand increases, and then in the evening it gets dark and we lose solar energy. So for this example, the best time to run things will be between 7 a.m. and 2 p.m. So at the end, I've got a slide with all the links here, but a couple of real-world examples. So Google do both time and location shifting. For examples like if you upload a YouTube video when it gets processed. Another great example is Windows Update. So when it downloads and installs updates, it takes carbon awareness into effect when it makes those decisions. And there's some academic research in this area. So there's a paper called Let's Wait a While, which some folks at the Technical University in Berlin worked on. And what they found was if you can shift to the weekend, you can reduce emissions by up to 20%. And if you can shift to the next day, you can still reduce by up to 5%. But yes, so to get this data, we basically need an API. And usually the raw data comes from the electricity grid. But there's a couple of providers that have coverage for multiple countries, which can be very useful. And the two most well-known are Electricity Maps and What Time. And they have free plans for non-commercial use, but the forecast usually needs a paid plan. So there's definitely some challenges about getting access to this data. So quickly going to talk about KEDA. So KEDA is a great CNCF project, and it lets you do essentially horizontal port order scaling based on custom metrics. And so it has over 50 built-in scalers like RabbitMQ or Redis, which is in the demo that I'm going to use here. And it also lets you scale to 0, which the regular HPA can't do, and is a nice sustainability feature. And so yeah, the carbon-aware KEDA operator was announced by Microsoft at KubeCon in April. I think also some folks from the Environmental Sustainability Tag also worked on it. And there's a proposal to integrate it into KEDA itself that's still in discussion. And so the way it works is it sets the maximum replicas for the KEDA, either scaled object or scaled job, and lets you do kind of demand shaping. And the nice thing with that design is it means it works with any of the KEDA scalars. So this is how it looks overall. So there's two main components. There's an exporter that's getting data from What Time, and it uses the carbon-aware SDK from the Green Software Foundation, which runs as a sidecar, and it saves that forecast to a config map. And then we have the operator, which is getting the forecast and processing the custom resources. And so once an hour, it sets the maximum number of replicas, and then KEDA takes care of the rest of the scaling and updating the HPA. So I've got a quick demo, which I just need to swap hands for. Yeah, so this is all running on my local Kind cluster. At the top, there's the operator itself. Then underneath, there's a demo workload. And this is just sending some random words into a Redis queue. So you can see these are just the random words that are being added. This is the Redis itself. And then these four are the ones that are being scaled by KEDA. And so these are just removing words from the queue, and that's the metric it's using to scale. The other one, this is the exporter itself with the sidecar that's getting the data, and then it's just saving it to a config map. Yeah, and so the forecast is stored in binary data in the config map. So this is reading it out. And so this is the What Time data. That cursor north is just as Northern California, and that's the free region that What Time give access to. And then for those time periods, for example, at the bottom, it's 424 grams. So that's how it gets the forecast. So this is the custom resource itself. The most important parts are here is where the config map's configured. This is an eco mode, which means that you can basically turn it off if you've got like core business hours where you don't want this to take effect. You can just turn it off here. And then this references the Kedar object, which is what we're updating. And then lastly, these are the thresholds for the carbon intensity. And so at the moment, 4 are running. And what I'm just going to do is I'm just going to edit that to 6, which I can do one-handed, hopefully. Actually, no, I can't. Okay, so hopefully, yeah, it's done it. So actually it's scaled up to 6. So that just showed how the scaling kind of works. Yeah, this is the last slide, all the links. I'll post these in the meetup as well. Yeah, and that's done. Does anyone have any questions?
Yeah, I had a question, and maybe someone else in the room can answer this. So I remember taking like an environmental policy class like 10 years ago and talking a bit about cap and trade as well as emissions taxes. So, and for example, like when I pay electricity, it is the most expensive when the carbon load is the highest. So I was kind of thinking, to some degree, we could also call this just kind of like the true cost evaluation to some degree, and like we're isolated from that by kind of the cloud's abstraction. Could you maybe speak to the kind of like how, or someone else in the room, how like cap and trade or like carbon taxes factor into the calculations of cloud computing, and whether or not, I guess it's kind of like a series of questions, like if it's only the case, for example, for very large companies where the cost that we see is like the market cost is reflecting that true carbon cost, or whether essentially that's something that only comes about through paying taxes. Like obviously there's a variety of systems in Europe trying to internalize those externalities of that carbon emissions so that it is reflected in the price. So yeah, that's something that I'm interested in, and was wondering whether you could speak to that.
Yeah, sure. I can try to speak to that. I'm not a big expert on cap and trade. What I would say, though, is I think more of the electricity pricing is moving to dynamic tariffs. And I think with dynamic tariffs, we can start to bring some of that in, and even eventually things like spot prices to introduce that into the cloud. But I think, yeah, but I'm not an area expert in cap and trade, so I can't really go deeper there, unfortunately.
Thank you, everyone. Unfortunately, we don't have much time. So thank you again for coming today, and a round of applause for our speakers. And we can all move to have a slice of pizza, and I think in half an hour we have to be out of this space. So we have a bit of time, but we have to move soon. Thank you.